Hello, am I audible? Hello, Oshim sir, Deepak sir, am I audible?
Yes, you are audible.
Okay, okay. Okay. This is probably the last live classes from our side. Today, actually, we'll wrap up these sessions by discussing the safety things, safety precautions during the handling operations of the hydrogen. And finally, I will show some of the live project. I mean, whatever I am studying, I'll show the my research topic and my research setup, and how the water electrolyzer is working, and the how I am storing the hydrogen, and I am measuring the hydrogen quantity as well as uh, this is week 12. Okay. As far as we concern the safety issues of the hydrogen, we'll measure this safety in terms of safety risk or element of risk. That is a multiplications of the probabilistics multiplications cost. That means probability of risk multiply cost in terms of cost in terms of cost in terms of capital cost. Okay, cost in terms of capital cost, or maybe human life cost. That is the in terms of safety measurement technique. These are all of the techniques you can measure. That is the quantitative risk assessment analysis and probabilistic risk assessment analysis. But these are the things you can do in future, or you can predict the risk where the hydrogen, when you will uh, using the hydrogen in industry or any places. There are three catastrophic failure, or there are some past incidents. Just I am explaining. This is very interesting, and just you listen carefully. Okay. Before that, I have to change one pencil nib. Actually, it is not working properly. 1 minute. Okay. The first one was the Hindenburg disaster. What was the Hindenburg disaster? It happens on 1937 on 6 May. What is showing in the picture that one one airship, what the airship it is carrying hydrogen, and this airship is painted with a conventional paint. During the during the running time of the airship, what is happening there? There will be temperature changes, and during the temperature changes, there is a lots of frictions between the air and the paint, or means outside of the tank, outside of the airship. And what will happen that there will be generations of the electrostatic energy, electrostatic field. This electrostatic field is unavoidable. Whatever the paint was used here, whatever the paint, whatever the paint was used in that spaceship, it was grabbing that electrostatic energy. I mean, electrostatic energy. You can know that when we will rub our hand, it will generate electricity in terms of electrostatic force, electrostatic electric field. When we will, due to the frictions, it will occur actually. This electric energy or free electron should be released to the atmosphere or should be released anyhow by joining one earthing or something that. But during the spaceship, when it is traveling in the air, there is no chances of removing this extra electron or electric field, electrostatic field by joining one earthing. It is never possible. Then what happens as the electron is accumulating over the paint surface of the spaceship? The inside the hydrogen, the due to the electric spark, one spark generated due to the high electric field or high electron electrostatic energy. Suddenly one electric spark generated, and this spark is enough to ignite the inside hydrogen. In this way, this failure was there during this is called the Hindenburg disaster. So it is it is necessary, or it is very carefully you have to design the any hydrogen tank or any hydrogen movable tank or any spaceship which is carrying hydrogen. Okay, at least you have to take care the paint also, outside the paint also. Okay, that is so much the careful you have to impose during the designing of any kinds of hydrogen equipment or hydrogen storage tank. This is the first type of failure. I think you will understand. Next is the hydrogen vapor cloud explosions. This was something in the year of 1989, Houston. It is it was polyethylene plant. There was a extensive damage of 22 lives and 100 injuries. What happened in that case? In that case, the failure was from the human sides. I mean, from the maintenance sides, or there are several flaws during the installations. I mean, there is a human error. This is this can be avoidable, as this is human error. But whether when such kinds of thing due to the paint, due to the unavoidable circumstances occurs, it is very difficult to avoid such kinds of thing. But human error can be avoidable by taking lots of care. Okay, so there was a lack of permit of the maintenance, design error with building ventilations, because you know that you have already studied that if hydrogen is leaking in a confined building or a confined space, what will happen? Then different effect will be there. I will discuss it. Okay, and you know that hydrogen is very explosive in presence of oxygen, open atmospheric oxygen. Okay, how much percentage of oxygen is, a very less percentage of oxygen is enough to burn or ignite the hydrogen. Okay, I will show you the data. This data is important also. Next one was the compressed hydrogen tank rupture. This was due to the material failure. There was welding joint. There was welding joint. What happened that this was, the failure was there due to the hydrogen embrittlement. Okay. Initially in the welding there was a very small crack. Okay. This crack suddenly or gradually it increases, this crack became larger and the hydrogen tank ruptures, and just compressed hydrogen tank was ruptured, and it was the failure was occur. When the hydrogen got when the hydrogen when the material got embrittlement due to the hydrogen or compressed hydrogen, what happened that the material behavior changes from ductile behavior to brittle behavior. This brittle behavior means that this is the sudden failure or sudden rises of the crack or sudden crack propagations. This sudden crack propagations may causes the hydrogen tank rupture. This was the three example. That was the different perspective. The different errors perspective was there, and these three different errors perspective lead to catastrophic failure of the hydrogen tank. Second one is the hydrogen vapor cloud explosions, and first one is the Hindenburg disaster. The incident related to hydrogen database is recorded here and it is plotted here. Then most of the, as of we know that the hydrogen is a very hydrogen. Okay, 1 second. Student is waiting. Okay. Over the past 100 years, hydrogen has a lots of applications in the different industry, but the industry are very cautious during the applications of the hydrogen or while they are using hydrogen. Okay, but most of the till now whatever the report is reported here, the all the incidents is reported here till now, there are most of the cases it was the due to the human error and the equipment failure. Okay, this human error and equipment failure, most of the cases was observed in the laboratory cases. Okay, and in some cases, next one is the fueling stations. During the fueling or refueling stations, there are the number of the cases occurs of the hydrogen related incident. And next one is the commercial facilities and power plant, and different cases the incidents was recorded and they are plotted here. What are the equipment failure? The equipment failure mean basically the fitting of valves in the pipe breakdown and pipe material rupture. Okay, due to the hydrogen embrittlement. Okay, and this is the major concern that leads to hydrogen related incident. Okay, and other incident like hydrogen storage equipment, vehicle and refueling stations, and safety systems, these are the other incident much there. Basically, pipe fittings and valves. These are the major concerns while you are working on the hydrogen. And the most of the cases, you have to take care the hydrogen refueling stations. And while you are working on the hydrogen in laboratory, you have to take care some precautions. These are the some incident related to hydrogen you can study. Okay, I will explain what are the important thing here. The interesting thing is that when the hydrogen will burn in clean atmospheric air, I mean clean environment, you cannot see the flame. It is invisible flame. Invisible flame will be there. Okay, but when any other gases except hydrogen, you can see the flame of red color or yellow color. Okay, or reddish yellow color you can see. But when hydrogen will burn in the clean atmospheric air, the flame will be like invisible flame. Okay, that's why it is very dangerous to work with the hydrogen or hydrogen setup. Okay, you know that it is very colorless, odorless, or not detectable by human sense. That means this is not detectable in human sense. Or this is and potentially ascoitants. That means it is a kind of human health hazardous related issues, like when the oxygen level when the oxygen level reductions of the oxygen level below 20%. When the oxygen level below 20%, this is important, you can remember, below 20%, below 20% oxygen level, there are different health hazardous issues will come. Human health hazardous issue. Human human health hazardous. When the oxygen level is below or in between 15 to 19%, in between 15 to 19% reductions of the oxygen level due to the presence of the hydrogen, there will be the reductions in the human activities. Whatever the human is normally, whatever the human is, different activities associating with the human, they may lose their activities or reductions in the human activity. This is reductions in human activities. When it is like in between 12 to 15%, 12 to 15%, the respirations problem arises. I mean, respiration increases and pulse rate increases. Okay, respirations RATION, respirations or pulse rate increases. Pulse rate pulse rate increases. When it lies between or oxygen, the more reductions of the oxygen, like I mean the presence of oxygen will falls between 10 to 12%, 10 to 12% oxygen. There are different glidness, Yes, yes. When the oxygen percentage below or lies between 8 to 10%, unconsciousness of the human occur. Unconsciousness. Unconsciousness of human. When the oxygen percentage become less than 8%, less than 8%, the life can be threatened. Okay, or human can go, life can be threatened, life can be dangerous, or some death concern will be there. Okay, these are the oxygen percentage when the hydrogen will leak, when the hydrogen and the reductions of the oxygen, these are the some symptoms will occur. So this is very very dangerous, or this is very very problematic while the hydrogen will leak. Okay, so we have to take care the or we have to reduce, or we have to take the safety measurement while we are playing with the hydrogen. Okay, and these are the things, you know. Next is, okay, the property of the liquid hydrogen associated with the accidents. How the liquid hydrogen is dangerous, and they may create some accident. These are the things we will study here. When the liquid hydrogen means that when liquid hydrogen will leak from any tank or any reservoir, then what will happen? They will stay close to ground and will move horizontal or downward directions. When the liquid hydrogen will leak from any tank, what they will happen? They will stay in the ground. But whenever the it exposes to the atmospheric conditions or atmospheric pressure and temperature, it started evaporating by taking the heat from the atmosphere. Okay, and the some evaporations will be there, some evaporations will be there, and what will happen during the evaporation, the buoyancy force will act in the positive directions, means the hydrogen gas will go upper direction. Is it okay? And and in another case, what will happen? This liquid hydrogen means its temperature is very very in cryogenic conditions, and temperature is less, about 20 Kelvin or 70 Kelvin. What happen? The atmospheric air like nitrogen, oxygen, or atmospheric moisture H2O, these will get condensed. When these gases of atmospheric gases will condense inside the hydrogen, what will happen? The concentrations of the hydrogen close to the ground will be high. Due to the high concentrations, the buoyancy forces will act in the negative directions. Okay, generally we want the buoyancy forces act in the positive directions. If the buoyancy forces act in the positive directions, the hydrogen will move in the upward direction, and the accident will be less, because that means the removal of the hydrogen through this confined space will be less, and there will be less chances of the catastrophic failure. Okay, this is the things. Sometimes what happen during the five hydrogen flow through the pipe, orifice and vent, it will get blocked. How it will blocked? If there is any moisture in the hydrogen inside the pipe, this moisture will get condensed and even they will accumulate in the ice form. Okay, and next when they will form after taking some heat from the atmosphere or any friction when the hydrogen will flow through the pipe, this ice will be converting into gaseous phase or liquid phase. Okay, during this gaseous phase or liquid phase, the volume will be expand, so the excessive pressure will be generated. This excessive pressure may causes the mechanical failure of the pipe. Okay, this is how hydrogen purity should be maintained. Okay, next one. Sometimes what happen, the when the gases condense, the volume of the gases will be reduced. Okay, and it will create some vacuum inside the hydrogen tank. Okay, suppose hydrogen is there inside the inside the hydrogen tank, the temperature is reduced due to the certain causes. Okay, and what will happen, the volume will be reduced, and due to the condensation of the gases, and it will create some vacuum, and due to the creations of the vacuum inside the tank, it may draw some air inside the tank. This air may get solidified or get stored inside the liquid hydrogen concentrations, and similar sort of problem will be there. Pressure will be rises when the it will converted, the phase will be converted from the solid phase liquid phase to gaseous phases. The pressure will be high, pressure will be generated, and this high pressure may causes the cylinder damage. Okay, just to avoid this problem, there is the positive pressure is kept inside the tank or inside the pipe flow. Okay, and this is important. Okay, this is important. Whatever the lines is there, the hydrogen safety covers the safety productions, handling and uses of the hydrogen, particularly hydrogen gas fuel, liquid hydrogen or liquid hydrogen. Hydrogen possesses a highest rating for 4 flammability. This is not important. This line is very important. Ignition can occur at a volumetric ratio of hydrogen to air as low as 4% due to the oxygen in the air. This means that when there is a 96% hydrogen in volumetric measurement, only 4% oxygen, only 4% oxygen may causes the chemical reactions with the hydrogen, and it will lead to explosions. That means when there will be the hydrogen storage inside the tank, there should be less than 4% of oxygen inside the hydrogen storage tank. It should not exceed above 4% of the oxygen. If it exceeds 4% of oxygen inside the tank, what will happen? There will be the chemical reactions with the hydrogen and oxygens, and it will form an exothermic reactions, and high temperature will be created and heat will be generated, and it will may create some explosions inside the tank. So hydrogen purity is very important. So purity of the hydrogen during the storage or any cases is important, or there will be no leakage, such that if the leakage will be there, the atmospheric oxygen will got interrupt inside the hydrogen, and there may be the catastrophic failure. So less than 4% or less than 3% hydrogen, less than 3% volumetric percentage of oxygen into the hydrogen is acceptable. Above the 3% of the oxygen inside the or mixture of the hydrogen oxygen, it is not acceptable. Okay. Okay. The next one is also important, just expansion ratio. This is very interesting. During the liquid hydrogen expanding process, when the liquid hydrogen expanded into the atmospheric pressure conditions, when the liquid hydrogen, I mean there is a liquid hydrogen, when it expanded into the atmospheric conditions, the volume rises will be very high, 847 times volume will be rise. Suppose 1 liter of liquid hydrogen is expanding up to 847 liter of the volume expansions when it exposed into the atmospheric conditions. Okay, so it is very dangerous, or you have to take care these things. That means that volume means it will occupy a large volume. If sudden any fire or any fire will catch this hydrogen, okay, this will be going to be very explosive. Okay, that means very large area you have to prevent. Next, the last data is like the gaseous hydrogen at 25 megapascal, when it will expand in atmospheric conditions, it will expand 240 times. The expansions will be 240 times. Okay, it is also a very large confined, it is also a very large space. Okay, so you have to avoid, the leakage of hydrogen, leakage of hydrogen. If the hydrogen will leak, then it will occupy a very large area, and in very large area, if there is a very small fire or small heat changing, the hydrogen may be explosive. That's why there will be no leakage during the hydrogen storage or any kinds of hydrogen operations system. You know the hydrogen embrittlement. During the hydrogen embrittlement, it is a material property that hydrogen will diffused into the material, and what will happen, and during the diffusion time, the interstitials, it will diffuse inside the interstitials of the metal, or it will diffuse into the different phase of the metal, or grain inside the metal. Okay, then what will happen, it is a very critical phenomena that the material property will changes from the ductile behavior to brittle behavior. That you know that the brittle behavior has a sudden failure. Okay, already I discussed in the earlier classes also. So hydrogen embrittlement should be prohibited, or should be taken care of. How the hydrogen embrittlement can be avoided? The hydrogen embrittlement can be avoided by incorporating improvement of the improvement of the material material. Okay, one second, one students is waiting. how the hydrogen embrittlement can be avoided? You can improve the material quality, improve the material, and some additives can be mixed. One second. Some additives can be mixed with the hydrogen such that some additives some additives into the material into the material into the material. These additives will resist the hydrogen embrittlement. Okay, next one is the we can make some oxide layer coating on the material surfaces. Oxide layer coating on material, or we can do reductions in stress concentrations just to avoid the hydrogen embrittlement concentrations. How these reductions of the stress concentrations will help to not forming the hydrogen embrittlement? How this is happen? The reductions of the stress concentrations means that suppose 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 one pipe suppose one pipe is there suppose one pipe is hydrogen is flowing through the pipe. Suppose hydrogen is flowing through the pipe. Okay, hydrogen is flowing through the pipe. In that corner, the stress the generations of the stress will be very high. Okay, when the hydrogen will flow or any liquid will flow, the stress concentrations will be very high in this zone. But when you design this pipe like this way, you just smooth or fillet this portion, the stress concentrations will be lower. The the stress concentration line will be follows like this. Okay, this way. So by changing the designing of the pipe or designing of the material, the failure can be avoided. Okay, that's why I have written here that reductions in the stress concentrations in the material can resist the uh, failure due to the hydrogen embrittlement. And it is very easy that the oxide layer coating on the material can resist the hydrogen penetrations or hydrogen absorptions into the material, and such that there will be no hydrogen embrittlement with the material, so we can avoid it the failure. Okay, so hydrogen embrittlement, there are three types of hydrogen embrittlement. Okay, there are three types of hydrogen embrittlement is there. First one is the environmental embrittlement. What is the environmental embrittlement? That the crack is propagated from the outer surface of the tank. Okay, suppose this is your hydrogen filled tank. The crack will be propagated, I mean crack will be generated from the outer surface to inner surface. Okay, this is the environmental embrittlement. Second one is the internal hydrogen embrittlement. Internal hydrogen embrittlement, that means the the presence of the inside hydrogen, it will lead to hydrogen embrittlement of the material, and the material property will changes, and the failure will be there. The crack will be propagated from the inside to the outside. This is called the internal embrittlement. The first one was the outsider hydrogen embrittlement, and next one is the internal hydrogen embrittlement. That means the crack will be generated from the inside hydrogen due to the presence of the inside hydrogen. Okay. Third one is the reaction embrittlement, hydrogen reaction embrittlement. Do you know the hydrogen reaction embrittlement? Any one of you? Reaction embrittlement. Any one of you know the hydrogen reaction embrittlement? Okay. What is the hydrogen reaction embrittlement? You have studied the metal hydride concept. You know that this is the metal, and hydrogen will come to the surface of the metal, then hydrogen will split into the hydrogen atom H, and this on the first H and this is on second H. This H will entrapped inside the metal, and this H will bonded with the metal side, and it will form metal hydride. And during the metal hydride, this total material will be expanded, or there will be some internal stresses. Due to the internal stresses, due to the internal stresses, the it will form some disorderness in will come in the size and shape. Due to the disorderness in the size and shape, the material can fail. This is called hydrogen reaction embrittlement. Okay, these are the three types of the embrittlement. You can you should know. Okay, the type of the hydrogen hazardous. There are the three types of the hydrogen hazardous: physiological hydrogen hazardous, physical hydrogen hazardous, and third one is the chemical hydrogen hazardous. Physiological hydrogen hazardous means there will be the some human symptom, or human will face some health hazardous issues. I have already discussed the how the hydrogen, how the concentrations of the oxygen will be low concentrations of the oxygen due to the hydrogen displacement inside the atmosphere will causes the human health hazardous issues like asphyxiations and overpressures. Overpressures, asphyxiations means that the this is the health hazardous. That means the human will feel some health hazardous. This is called asphyxiations. Okay, this is actually health hazardous, human health hazardous. Like the human is suffocating, or um, human is feeling some problem in their respirations on, and as well as the pulse rate is increasing. These are the type of asphyxiation problem issues in the human health. Overpressures, you know that the when the hydrogen will, when the liquid hydrogen or the high compressed hydrogen gas will lead to some fire, when catch fire, the some it will burn and it will be explosive, and the high pressure will be generated. These are the all the things. And thermal burn, the thermal burn, due to the high temperature and heat of the hydrogen explosions time, it can create some burn on the human skin. Okay, and cryogenic burns is also there. That means low temperature burn, this is the high temperature burn. Okay, embrittlement, you know, the environmental and internal and hydrogen reactions is this is, you know, the chemical rupture and explosions, fire, and vapor cloud explosions. Vapor cloud explosions I have discussed. Okay, next is the explosions. there are the term, two term is associating with the hydrogen. One is the explosion. This is the first term. One is the explosion, and the second term is the fire. There are the two different terms. The explosions is the different term, and fire is the different term. Okay. It does not mean that the explosions means that the fire is there, and fire means not that is explosions. Explosions means the it will increase some high pressure will be rise, the increase of the pressure, okay, and rapid release of the hydrogen, okay. Explosions means that the hydrogen is releasing in a high pressure, in a high speed. This is the explosions. And fire means that the some it will come into the, it will come in the ignition temperature and it will ignited, and then the it will fire, I mean it will catches fire and it will burn, okay. This is called fire. And explosions means it is not fire. Explosions means high vapor pressure, high vapor pressures, you can say also high vapor pressure. Why the vapor is coming? When it is coming to the atmosphere or it is exposing to the atmosphere, it will take some heat from the atmosphere, and it creates some volume expansion, and due to the volume expansion it will create some pressure, okay. And this due to the high pressure, this due to the high pressure so the hydrogen releases, this is called the explosion, or high pressure, high vapor pressure. This is not vapor actually, this is high pressure, or high pressure, okay, you can write. Deflagrations means that the flame front moves through a flammable mixture in form of subsonic wave. This is more high speed, this is in high speed, okay, to the unburned mixtures. What is happening here? When the hydrogen will expose to the atmosphere, when the liquid hydrogen will expose to the atmosphere, what will happen? Okay, what will happen? The the outer part, the outer part of the hydrogen will evaporate. This is evaporated, outer part of the hydrogen, but inner part will not evaporated, okay. Due to the outer part evaporations, and the outer part comes in contact with the atmospheric oxygen, and it will burn, but inside the liquid it will not burn, it is yet in uncombustible form, okay. This uncombustible form when create some subsonic wave, or means high flame propagations, okay. These high flame propagations will create deflagrations, okay. Detonations, you know that it is due to the shock wave propagations through a detonable mixtures in the form of supersonic wave, okay. That means detonations is very dangerous than deflagrations, okay, because the it is in the supersonic wave, it is very high velocity, okay. It propagates 1,000 times faster than the deflagrations, okay. And next is the BLEV. What is the full form of the BLEV? This is boiling liquid expanding vapor explosions, okay. Boiling liquid expanding vapor explosions. Whatever the things, when there is the late fire into the hydrogen, or when the hydrogen will be releasing, when the late fire, what will happen that this hydrogen will get vaporized, or this hydrogen will be get vaporized, and it will create some spherical ball type, whatever I am discussing before, liquid hydrogen cases, for these cases, it will create some firewall. This is called firewall actually. Okay, and flash fire is it is very diluted, or it may be very concentrated fuel mixture, but flame travels in cloud at low speed. Initially it was very high speed, but in that case it is very low speed. Suppose what happened, suppose there is one tank, suppose the tank, there is one hole, pinhole, there is one pinhole. Due to the pinhole, the hydrogen will release in a very faster speed, and this will create some fire jet. And when the hydrogen will, there is the a large hole, and when there is a large hole, what will happen, the hydrogen will not coming out in a very faster speed, the speed will be very less, and what will happen that, and the hydrogen gas will move in the upper directions. Okay, due to the buoyancy forces. Okay, and there will be some relief that hydrogen will not accumulated, or hydrogen will not be so much harmful due to the flash fire, just it will evaporated and go upside. Some term I will discuss here. This is some important term, like I should discuss. Okay, just I am discussing some important, that the property changes at the low temperature. What the property changes in the low temperature? Suppose in a hydrogen vessel, we know that at high temperature the material property will changes, but simultaneously at low temperature the property will also changes. Like the property changes, like there is a phase changes, phase phase changes, the phase of the material will changes, or some cases the phase transformations will be there. There will be the some thermal contractions due to the low temperature, thermal contractions of the material. Due to the thermal contractions of the material can fail. Okay, so not only the high temperature will deteriorate the material or hydrogen vessel material, as well as low temperature also has some, create some problem in the hydrogen storage tank. Okay, this is important. Okay, next one is the liner blistering in pressure vessel. What happen, generally the type 1, type 2, type 3, type 4 tank is used for hydrogen storage. What happened for the case of the type 4 tank? Type 4 tank is the most appropriate one to store the hydrogen, as it includes that, as it includes that the carbon fiber wrapped over the tank, carbon fiber carbon fiber wrapped over the tank, wrapped over the tank, and inside there is the polymer inner liner, polymer inner liner, polymer inner liner, inner liner. Okay, this is the type for tank. You have studied type for tank. Sometime what happen, the inner polymer may absorb the hydrogen, and this inner polymer absorb the hydrogen, and the polymeric strength will be reduces. Okay, this polymeric reduces, and it can causes the failure, as well as when the polymer will absorb the hydrogen, it will it will be in stress difference, or mean sometimes it will depressurizations, or sometimes it is in pressurizations conditions. Sometimes pressure difference, you can say that it is in pressure difference or stress difference, it is in the stress difference. Due to the different stress or stress concentrations into the polymeric material, it can fail, or it can create some liner blistering in the pressure vessel. Okay, these are the important things. uh, when the hydrogen gases releases, there will be the two options. One is the immediate ignitions, when there will be the delay ignitions, and second one is there will be the no ignitions. Okay, suppose hydrogen is leaking from this tank, there will be the suppose some sort of ignition point, or some sort of fire is there, it will ignite the hydrogen immediately. Okay, it will be explosive, and when there will be the some delay ignitions, what will happen, the immediate ignitions, during the immediate ignitions, it will immediately catches fire and it will be explosive. And delay ignitions, what will happen, when the delay ignitions will occur, the delay ignitions will be there will be the, suppose if the ignition is delay, I mean the hydrogen gas is leaking, and after sometimes it is ignited, that means the time at in between that time the hydrogen will be go upside due to the buoyancy forces. Okay, and there will be the less concentrations of the hydrogen, it is less flammable mixtures will be there for the delay ignitions. Okay, and rupture of the vessels will be there when this high pressure hydrogen will leak from the hydrogen tank. Okay, it will create some pressure difference inside the tank, and due to the pressure difference inside the tank, the vessel can be damaged, or the rupture of the vessel will be there. Okay, as of now it is 1 hour. First I will go to the questions, and all the slides is added here, you can study. Okay, this is important, you can study. China is the major, the China is using hydrogen fuel, or hydrogen gas in their in industries. China has number one user or producers of the hydrogen throughout the global. Okay, China, Japan, European Union. Okay, I am coming to the first questions. Okay. The greatest number of the hydrogen related accident occur. The greatest number of the hydrogen related accident occur. Hello. Huh. The greatest number of the hydrogen related accident occur inside the
In
laboratory, inside the
laboratory only.
fueling stations,
Laboratory.
power plant, and onboard hydrogen storage in vehicles. Okay, this is obviously laboratory because you know that the hydrogen related incident will is there only due to the human error and some cases of the equipment failure. So in the laboratory and the equipment failure is the major concern of such kinds of incident. Okay, so the study says that the laboratory is the major or higher related or higher number related incident related hydrogen issues or death. And what happened during the fueling stations? What happened during the fueling stations? You know what happened during the fueling stations? Any one of you? What happened during the fueling stations when the suppose this is your car, suppose you have to fuel it with the hydrogen. During the fueling, the heating will occur. Okay, during the fueling, the heating will occur. During the fueling, the heating will occur. And suppose the during the releasing of the hydrogen, suppose this is your tank or this is your tank, and you are releasing hydrogen. This tank is getting cold. Okay, so the releasing of the hydrogen, releasing of hydrogen during the releasing of the hydrogen, the temperature will be reduced, and during the filling of the hydrogen, the heating will be there. Okay, so what happened? So what is the precautionary measurement during the hydrogen filling inside the tank or inside your car? What is the precautionary measurement you can take as a hydrogen expert? What would you suggest? So as an hydrogen expert, you can say that during the filling of the hydrogen, it should be in a very faster way. So as fast as possible. So faster filling, faster cooling, sorry, faster filling of hydrogen or faster releasing of a hydrogen. Faster, FASTER. Faster cooling of faster filling of matlab refueling of hydrogen inside the tank, inside or inside the car is needed to avoid the higher heating value or to avoid the high heating chances or during the cold conditions. So cold is also, I mean, cooling is also dangerous for the hydrogen when hydrogen is released because this temperature drop will causes the this temperature drop will causes the material failure. You know, okay. This is clear now. Is it clear? Okay. Next one is the which among the following is physiological hydrogen hazardous? Physiological hydrogen hazardous means it is related to physical health. Okay, physiological hydrogen hazardous. Physical health mean human physical hazardous. What will be the right answer?
Option D. Option
Option
D.
D.
Asphyxiation.
Uh, asphyxiations. Asphyxiations means I already told you that the it is related to the human health hazardous issues. Human health hazardous issues means a different type of human health hazardous issues like pulse rate will be high or maybe there is a problem in respiration systems and it may be when the high amount of the hydrogen will be there in a confined zone, I mean less amount of the oxygen will be there, less percentage of the oxygen will be there, or below 8% of oxygen if is there, it will create or it will lead to human death also. Okay, so asphyxiations is related to the human health hazardous issues. Okay, so our option D is the right answer. Okay, next is the question number 3. Which among the following is not related to material property causing hydrogen hazardous? Material property means that the material related problem. Suppose hydrogen embrittlement is there in material, and material property changing from ductile property to brittle property. Okay, this is kind of failure of the material failure. Okay, like liner blistering failure. It is liner blistering means that the liner blistering means I already discussed that it is change in stress. Okay, sometimes stress is 100 pascal, sometimes it is cyclic process. Okay, sometimes it is 10 pascal. Okay, when the change in stresses or cyclic stresses is there, or it is called exactly cyclic stresses also you can say, or repeated stress you can say. Okay, when the repeated stress, due to the repeated stress the material can fail. Can you quote one example, the material failure due to the cyclic loading? Anyone have any ideas due to the cyclic loading failure, material failure? Suppose suppose you have one very small copper wire, small small thickness copper wire. Okay, if you just apply the copper wire some stress like this, just bend, you just bend it 100 times, 1000 times, it will crack, or uh, it will be in two parts. If we bend for 1000 times, you are bending it in 1000 times means you are creating some repetitions of load. Okay, you are releasing some load, you are giving some load, it will just bend it and straight it, bend it straight it, and it after sometimes it will fail and you will get into two split. Okay, this is the repeated stress. Okay, this repeated state stress is related to the liner blistering. Sorry, answer is not. Uh, huh. So this is the liner blistering. The damages of the carbon fiber. You also know that the damaging of the carbon fiber also may damages. Okay, due to the hydrogen embrittlement and stress is generated inside the carbon fiber. And next is the boiling liquid expanding vapor explosions. Boiling BLEVE. It is boiling liquid expanding vapor explosion. You know that when the liquid hydrogen is coming out, the outsider surface of the liquid is getting vaporized, and this, and inside hydrogen, liquid hydrogen is still remain liquid hydrogen, and it will create some high pressure due to the phase difference.
Answer answer is BLEV.
Answer is BLEV, but I am explaining the what is the VLEV. Okay, but inside liquid hydrogen is still in liquid conditions or non combustible form, and it will make some high pressure. Okay, and this is called the, and it will explosive, it will expand in at a very high pressure. This is called boiling liquid expanding vapor explosion and embrittlement, you know. So our answer is C. Okay, this is our answer. Question number 4. Which phenomena among the following will occur on immediate ignitions of gas? There are the two things. One is the immediate ignitions of the gas, immediate. One is the delay. One is the delayed. Okay. For the question is asking for the immediate ignitions. Okay.
So it is jet fire.
Ha. Uh, can you explain why the immediate hydrogen, immediate ignitions causing jet fire or flash fire, and delayed ignitions will causes the
Explosion.
explosions, high explosions.
Yeah,
Anyone
because
of you can explain?
yeah, because of how from gas, if gas come
Hmm.
out of high pressure,
Hmm.
okay, so the gaseous to gas is not mixing with the air,
Hmm.
so there will be no fire, but outer surface of that gas
Hmm.
will have sufficient air mixture. Okay, so outer surface there will be fire, but inner surface, core of the jet will have high density, so
Hmm.
there will be no fire, and it will propagate.
Ah.
So that is called jet, and
Ah.
along with the fire outside it.
No, that is okay. That is acceptable. But here I am asking that the immediate ignitions means your the hydrogen is releasing from the hydrogen tank, and you are putting one match fire inside the hydrogen. That are you are immediately putting fire on that jet, on that releasing of the hydrogen. It will create jet. Okay. Why? My question is that. But it is the concept is whatever I have discussed. You are telling it is okay. In that
No.
case, in that case what happens, suppose this is your hydrogen tank. Suppose there is one leak, the hydrogen is coming out through the leak. I am putting immediate fire to the hydrogen. Okay, just hydrogen is leaking here, just I am putting immediate fire. This is called immediate fire. But late fire means that the hydrogen is leaking, hydrogen is coming outside, the external fire I am not giving the external fire. Okay, I am giving external fire in a very late. Okay, but when I am giving the external fire or external immediate ignitions, what will happen, just hydrogen come out from the tank. Okay, it will got fire, it will catch fire. Okay, it will catch fire, and all the reactions will be there, and due to the catch fire or due to the buoyancy forces of the hydrogen, the the fire will go upside direction at a very high speed. Okay, and total combustions will be there. Okay, but when the delayed when the delayed ignitions, what will happen, when the suppose this is your tank, the hydrogen gas is releasing. After releasing, what will happen, after releasing hydrogen gas will be go upside, the concentrations will be very less, the concentrations will be low. If I put the ignitions or fire inside the into the hydrogen, the concentrations will be less, and there will be not explosions will not be there. There will be not immediate jet will be not there, but explosions will be there, and high knocking will be there. Okay, this is called, I mean, high pressure difference will be there. Okay, but in that case total hydrogen will get fire, catch fire, and it will go upside, and it will this process will be at very high speed. It is like jet like speed. Okay, that is the two difference of the immediate ignition and the late ignitions or delayed ignitions. For the delayed ignitions, the hydrogen will already concentrations of the hydrogen will be less, and some hydrogen will go upside due to the buoyancy forces. The concentrations of the hydrogen will be less, and after sometimes that it will create some vapor pressures, I mean explosions, uh, then in that case it will be explosion form. Okay. So our answer will be, for the case our answer will be jet fire. In that case immediate ignitions it will be coming out at very high speed. Okay. So our answer is the jet fire. Next one is the, which among of the following is the advanced quantitative risk assessment models?
It is discrete dynamic
Ha,
event tree.
discrete dynamic event. If
Event tree.
ha,
Others are the normal traditional model.
there
So
are the
event
non
tree,
model.
fault tree, and parts count.
Ha,
It's a traditional model and discrete dynamic event and other some other event sequence diagram, sampling and simulation based. These are the
ha.
advanced ones.
These are the all the simulations based, but the this is the advanced method. Do you know the discrete dynamics event tree?
No, no.
Ha. Actually, what the name suggests, discrete dynamic event tree.
It's the sequence of the events basically. Sequence of the events. So you are analyzing that the
This is the fault analysis technique, advanced fault analysis technique, or advanced failure technique, such that we can assess the risk. We can measure the risk assessment, or we can make some model of the risk assessment model. The discrete dynamics, for any cases, now the scientists are using the discrete dynamics process, but I am not working in the discrete dynamic analysis process, but every cases everything, suppose if you study the FEM process is a finite element method. Finite element method is also on discrete analysis dynamic analysis process. FEM, FEM process. Why this is called discrete? Discrete means, suppose discrete means, suppose this is your one tank, or suppose this is your piston cylinder, any material. Suppose I am analyzing this material property, or material failure property. This discrete dynamic event tree analysis, it will create very small it will discretize, it will create very small
and this is like the finite element.
finite element method, exactly.
Yeah,
That's why
number
ha
of
number of the
cells. If
discretization
you
cell will
increase
be
the number of
large,
cells, the result will be very
more
close.
accurate.
Yeah.
Exactly. Next one is the six, question number 6. What is the expansion ratio of a leak of gases hydrogen store at 25 megapascal to atmospheric pressure?
So it is 1 is to 240 because
One is to 240.
25 MPa is around 240
Uh,
and outside it is 1. So it is
hmm.
240. 1 is to 240.
240. This is your correct answer. But why this large volume of expansion is dangerous in the case of the hydrogen? Why not, suppose, why not for the CNG? My question is like, this volume is very high. If hydrogen will leak, 1 liter hydrogen will leak, 1 liter gaseous hydrogen will leak, it will occupy 20, 240 liter space. Okay, this 240 liter space means a large, the contaminations of the large area of the hydrogen will be there. So large contaminations is dangerous, always dangerous. Okay, large contaminations means that the large risk is associated here there. Okay, so that's why this volume is important actually. Okay, so we should not, uh, we should avoid the leaking of the hydrogen. That's why this questions is signifies that uh, when the hydrogen leak will be there, it will occupy very large space. Suppose it will occupy one total building. Okay, if the 1 liter hydrogen will leak, it will occupy one large building. Okay, I'm giving one example for the example. Okay, that's why the total whole large building will be in uh, serious conditions or maybe in danger conditions. Okay,
So what is this VF by VI? Yeah, and NBP
which one?
in the left corner and right below right bottom corner. So it
Right
is
bottom corner.
Final and initial. V final versus V initial.
Acha acha, हाँ.
okay. Final. Okay, okay,
V
okay.
final versus V initial. हाँ. This is the pressure P and V for volume. We are talking about the volume. Okay, volume expansions. We are talking about the volume expansions. Sorry, atmospheric pressure is expansion ratio means volume expansions. Expansion ratio. Uh, Question number 7. The percentage reductions of the oxygen level in the confined space due to release of the hydrogen can increase human pulse rate. This is obvious. Suppose in a confined space, suppose hydrogen is leaking here and hydrogen is coming inside the confined space. What will happen? The oxygen will displaced. Hydrogen is coming. The oxygen is displaced there. O2 will be go outside and it will filled with the hydrogen and oxygen percentage will reduced here. Okay, and what percentage reductions of the oxygen level in confined space due to the release of the hydrogen can increase the human pulse rate?
I think it is 12. Yeah,
To
12 to
19, I
15.
think. 15 to 19.
I already discussed it in your first PPT slide. You will just see and you will write it all the form. I have discussed if it is below 20%, it is 20%, 15 to 19%, 12 to 15%. If the reductions is below 20% oxygen level, some human health hazards will be there. If the it will 15 to 19% reductions in the human activities will be there. 12 to 15% it is the increase in pulse rate, respirations problem. Okay, and 10 to 12% giddiness and 8 to 10% unconsciousness and less than 8% human can death can occur. So our answer will be 12 to 15%. So our answer will be B. Okay. Okay. Question number 8. Question number 8. Uh, Wait, just someone is waiting. Okay. Just wait. The question number. Just wait. Question number 9. How much percentage of refineries present hydrogen
Sorry,
demand?
question number 8, please.
Oh, question number 8. Okay.
Hmm.
Question number 8. According to National Hydrogen Energy Mission, the dash of hydrogen blended with CNG wheat will utilize as a fuel for transportations. Actually, what happened?
18%. 18%.
Okay, this is okay. Actually, what happened? The advanced country like USA, Japan, China. China is the most advanced country. Okay, for utilizing this hydrogen as a fuel as well as hydrogen reductions, hydrogen used in the refinery, and hydrogen as well as productions of the hydrogen, like byproduct of the hydrogen, or electrolyzer, the productions of the hydrogen from the electrolyzer as a green energy, green hydrogen. Okay, they are the in the top most positions for utilizing, for the in the case of the utilizing as well as the productions of the hydrogen. Okay, so what happened, we the India are little behind, but the national in the national hydrogen missions, there is a target, there is a target of, this is important, there is a target of 5 million ton of green hydrogen will produced. Okay, this is our target. Okay, this is our target. This is the target for the India. Okay,
So this
so
target is by uh,
by actually 5 years, it is by 2026.
okay.
Okay, just let me check. Actually there are the two target. One is the up to 2030, and
I think this is by 2030. So 5
2030.
million.
uh,
Yeah.
this is 2030, and a final target, globally target was there, 2050. Okay, sorry, 2050. 50 is the another target. The first target is to produce, the first target is to produce the total transportations vehicle, 50% conversions of the vehicle with hydrogen fuel by 2030, and total 100% conversions of the 100% conversions of the hydrogen fuel, transportations bus or like this truck, it is by 2050. Okay, there are two target, globally two target is there. Okay, so for the India is, as the India is the beginner of this research and development and all the things, there they will uses it as a fuel. I told you that this fuel is not efficient when this hydrogen fuel is directly used in combustion. So when we will mix the 18% of hydrogen, 18% of hydrogen, 18% of hydrogen with the CNG, remaining 78%, sorry 72%, 82% remaining CNG, CNG remaining 82% CNG, 82% CNG, that means it is using in the combustion process. So the combustion process efficiency is less. Okay, the combustion process efficiency is less than 20%. But this hydrogen, if is used in the fuel cell, and the efficiency will be like 70% or 70 to 80%. So the better way to use the hydrogen is using in the fuel cell. Okay, not in the with the CNG mixing. Okay, but yet we are, the target is there, 18% hydrogen will mixed in the CNG. Thus we can avoid, or we can save some money by utilizing some existing pipeline of the CNG pipeline. Okay. Question number 9. How much percentage of the refineries present hydrogen demand is supposed to be met with green hydrogen as per green hydrogen or green ammonia policy of the government of India?
So for refinery it is 10%.
Ha. Actually, what happened for the refinery? It is 10%. Just you keep remembering these data. I don't know. The data may ask in your questions. Okay, but these are the basic
And
data.
ammonia is 5%.
Ammonia is the
10%
5%.
10% is refinery, and next 5 years it should be 25%, and
25%.
5% is ammonia, and next 5 years it should be 25%.
Exactly. Next 5 year, 20% in the next 5 years. Actually, it is not good that I am using gray hydrogen or black or other hydrogen or blue hydrogen or other hydrogen, but the target is on the green hydrogen. Why the green hydro? What is the green hydrogen?
so we generate lesser than 2 kg of carbon dioxide to produce 1 kg of hydrogen.
No, the green hydrogen means this is all about the carbon capture sequestrations, carbon non-carbon carbon capture without sequestrations. The green hydrogen means I
With
am produce huh?
non-conventional sources,
Non-conventional, but exact meaning you should understand. Just learn the exact concept. The green hydrogen means it is totally green. There is no carbon footprint.
carbon generation. Yeah.
How the no carbon footprint will be there? If I only uses the solar power, SOLAR, solar power as a energy, solar power. This electric energy, solar power will produces electric energy, EV, electric energy. This electric energy will be utilized in the electrolyzer. This electrolyzer will produce hydrogen. This hydrogen is called only green hydrogen. There is no carbon footprint in this process. There is no carbon footprint. But when you uses this electricity, suppose thermal power plant electricity you are using to electrolysis this hydrogen, it is not called green hydrogen. Okay. Okay. But some literature is saying that it is producing below 2% hydrogen carbon
No, no,
dioxide,
no,
it is
no,
called.
no. Actually, National Green Hydrogen Mission, they set this definition on August 2023. It says what is the green hydrogen? So it
Ha.
says, yeah, it says that I am reading that the greenhouse gas emission arising from the water treatment, electrolysis, gas purification, and everything, it should not generate 2 kilogram of carbon dioxide equivalent per kilogram of hydrogen. So,
Exactly. But
yeah, so
whatever the national green hydrogen missions they have adapted or they have written, it is wrong. Okay, the exact definitions of green hydrogen is this one. Okay, but India is wants some sort of. I am using electricity from our lab. This lab electricity is coming from the thermal power plant. Okay, but the exact definitions of the green hydrogen is this one. Okay, but India is taking this policy, you can use electricity to generate hydrogen. Okay, that is debatable form, but the exact green hydrogen terminology is coming from this concept. Okay.
in that case, no hydrogen is basically green because you are generating from solar. If
Hmm.
you are generating from solar, okay,
Hmm.
so there is inbound carbon also. So during the manufacturing of solar cells and all the materials,
Okay.
okay.
uh,
So if you see the ideal case, there is no green hydrogen
no
at
no
all.
no huh. In ideal case means after the productions, your during the productions there will be obviously the carbon emissions, lots of carbon emissions from the industry will be there. But after the production, it is coming green. It was one time, but during the thermal power plant, it is continuously generating electricity, or you are taking this electricity to generate hydrogen in the electrolyzer. That is not green actually. Or any kind, solar energy or wind energy, hydrothermal, geothermal, this sort of renewable energy are like of uh, used in the used in producing the green hydrogen. Okay, just you will Google it. Does the green hydrogen means? I have studied. Okay, uh, so you can understand what is the exact definitions of the green hydrogen. But these are all about the carbon capture sequestration process. This is not green hydrogen. Okay, but I can we can say green hydrogen as the green hydrogen definitions is different. Different people has defined it in the different directions. But exactly this is the process and global system.
So Indian definition, is it different from other like China and all
Uh,
other 30 countries they have already declared?
Whatever all the scientists, all the global government are trying to release less amount of the hydrogen. Okay, less amount of the hydrogen. This is the process. This is the main priorities. I will produce less carbon dioxide, less nitrous oxide, less SOx, NOx. Okay, this is the concept. When it will be zero, it is green. You can consider that it is 1% producing carbon dioxide, it is green. You can consider. Okay, but the percentage is debatable firm. But green means it should be zero, but we can assume 1% carbon dioxide. Okay, next is the next. I will show you one video. Just let me complete it quickly. Question number 10. The
So,
20%.
1 minute. So
Uh,
in that case,
hmm,
only the hydrogen generating through the electrolysis process will be
yes.
considered as green hydrogen, nothing else.
Ha. Till now, there is no process to generate the hydrogen without generating carbon dioxide, SOx, NOx. There is no process. Only the electrolysis process. Only one process to generate green hydrogen. Okay, or even then, this energy will come from the solar energy, wind energy. Okay, I will show you my setup. Actually, it is getting late. Question number 10. The 20% hydrogen blending with the natural gas can offset carbon intensity by
7%.
7%. Okay. This is all about the MCQ related discussions, and MCQ related discussions, and you will go through all the live sessions or all the notes what you have till now you have collected. Just prepare well in your final examinations, and do the best, and you score highest, and for the all the best for your exam, and as well as your personal professional business, as well as in your job field. I am showing you one video. This is my setup. Is it visible, Asim sir?
Yes.
Yes,
Yes,
it is
yes, it
visible.
is visible.
Not yet,
No,
not yet.
not coming
Not
up.
yet started. Okay.
Yes, yes, it's
Started.
coming.
This is my setup. This is hydrogen gas collection. So this is my setup. I will explain. Again, I don't know. This is the way I am measuring the hydrogen. This is the displacement process. This is the liquid displacement process. You understand that I am putting one pipe here. I am putting one pipe. Just laser. Okay, laser. Okay. I am putting one pipe. This pipe is coming directly from the electrolyzer outlet, from the cathode side. As you know that the cathode is generating hydrogen. Okay, cathode side. This pipe is fitted or put inside the volumetric cylinder or measuring cylinder, and this inverted measuring cylinder, and it is filled with initially filled with water. Okay, this is initially filled with water, and when the hydrogen gas bubble is coming upper portions due to the buoyancy forces, the it will displace water, and water is going downer or coming out, and the hydrogen gas is occupying on the topmost portion, and this filled with water filled inverted cylinder is dipped into the water filled uh, another 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 beaker. Is it clear? And this is how I am measuring the hydrogen productions.
Yes, yes,
Okay.
clear.
Next is the this is the oxygen and this is the hydrogen. How this is how I have fitted, and this is the hydrogen is gas is coming. And after this, I checked the hydrogen gas purity in the lab of gas chromatography GC. This is the electrolyzer, single cell electrolyzer setup. My single cell electrolyzer setup. This is, and one heater sensor is put here because it is just sensing the temperature. At what temperature I am doing this experiment. I'm doing the experiment at 50 degrees centigrade. Actually, it is showing
So
49.
it is sensing the temperature of the atmosphere there, or
No, no, no,
the
no, 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 no.
temperature of the
Liquid
uh,
inside liquid water,
okay.
water, because water should be fed at high temperature. It should be around 80 degrees centigrade. But I am doing 50 degrees centigrade because some another type of membrane I am preparing, some novel membrane, bipolar membrane I am using. But generally it is proton exchange membrane or anion exchange membrane water electrolyzer is there. But due to this, this has some advantages. That's why I am using or I am preparing this bipolar membrane. This is your pump. Actually, this pump is water is fed inside the electrolyzer. Okay, this is also a small video. It is also uploaded in the International Journal of Hydrogen Energy. One of paper I have published. You can see, you can go through the paper and you can download this video. Okay, just you will search the my name Subrata Kumar Maiti in the Google Scholar. You will find it. Uh, okay, this is the thing, and the exact setup just I am showing you in details. Is it visible? Slide is visible now.
Yes.
Yes,
Uh, you can uh, fuel cell. This is very small now. Okay, just I have to copy it and then I will zoom it in the next slide. Then only you will understand. My computer is actually getting slow. This is fuel cell. This fuel cell is in our lab. This is the fuel cell. Is it visible? This is the fuel cell. This is the fuel cell, and this is oxygen cylinder. This is oxygen cylinder, and hydrogen cylinder is kept inside another room. We are taking some preliminary measurement. Okay, hydrogen cylinder has kept not in that zone, but we have kept some separate way, separately. Okay, uh, there is this is the hydrogen supply. The hydrogen is supplying here, in through this pipe, and the oxygen is supplying through this pipe. Is it okay?
Yes.
And we are controlling the flow rate by using this valve. This is some pressure gauges, and there is some pressure gauges, and this is the flow rate measurement. Okay, this is flow rate measurement. We can control this flow rate, and how much pressure I desire, it will show this pressure. Okay. Then the oxygen will come. Then the oxygen will come to this humidity chamber. This is the humidity chamber. This is humidity chamber means it is filled with water, and white color it is the heater. Okay, the same thing is for the hydrogen. This is oxygen. Suppose this is oxygen, this is hydrogen, this is hydrogen, and the gases will go through the chamber, and the dry gas will get some wet conditions. I mean, it will absorb, it will capture some moisture. Okay, this moist air, this moist hydrogen and oxygen gas will go inside the fuel cell. This is the fuel cell. The oxygen will go into the cathode of the fuel cell, cathode, cathode, and hydrogen gas will go inside the anode of the fuel cell. Okay, and there will on membrane will be there. Suppose proton exchange membrane will be there. Okay, suppose proton exchange membrane. Suppose cathode is negative. This is oxygen fed, and anode is positive. This is hydrogen phase. This is hydrogen, and this H, it will due to the oxidations reactions of the hydrogen in the presence of the moisture water, it will produce H plus ion. This H plus ion go through the membrane, and it will attract to the cathode, and it will react, it will reductions will be there in the cathode side, and the external electric field, electric circuit is there, just to measure. There is one load. This is the load, electronic load. This will measure how much voltage I am getting. Okay, this is the fuel cell setup. Next one is the electrolyzer setup. Already you have seen. Next is the electrolyzer setup. Just I am copying it here. Is it understandable little bit of whatever, how the setup is actually there? For the electrolyzer case, you know that this is some special, some latest type of electrolyzer. That's why it is a bit different. But generally, what happened that in the anode, suppose this is anode. Suppose here this is cathode. Actually, this is minus. In the anode is opposite. The water is fed inside the anode, and for the proton exchange membrane, the anode H plus ion will come to the cathode side, due to the cathode side when we will apply the some external electric field. I am giving some external electric fields by applying the DC power source, external DC power source. Okay, it is DC power source, not AC. Okay, DC power source, and the water will split and dissociate, and it will water splitting reactions will be there in the anode and cathode, and it will produces hydrogen will produce in the cathode negative, negative hydrogen, and positive oxygen, anode oxygen. Okay, then oxygen I am measuring. Okay, this is my setup. Okay, these things I promise you in the first classes, during the starting of the classes. That's why just I tried to show you the set up in our laboratory at IIT Roorkee. Uh, Hello.
Okay, thank you, thank you. Yeah.
Okay, thank you. All the best. If you have any questions or any sort of questions, or maybe out of the box, you may ask. When will be the final exam?
2nd of November.
End of November.
2nd of November.
Acha, 2nd of November. Acha, 2nd of November. It is already fixed. Okay. 2nd of November. There is okay, 20 days you have.
Yes, almost.
Yes, yes. Okay. Just you prepare well, and best wishes from my side, because
Yeah, we'll put our
Thank you.
question. Yes, so don't get out of the what is called the group.
hmm.
Okay, so
Okay,
we'll
okay.
ask you request some I mean
Okay,
answer
if you
might
have
answer.
any
Okay.
problem, we always will try to solve or try to help you. Okay, help you out. Okay, we will not exit this group, because okay, we can help each other in future also.
Yeah, sure, sure.
Okay, okay,
Thank you. Thank
okay.
you.
Thank you, thank you, thank you. Okay,
Thank you.
okay.
Yeah, thank you.
Thank you.
Bye.